We are solving radical equations. It is important to remember when solving a radical equation that you first have to have a radical by itself. And so when I look at this first example, I will notice that this radical is not by itself because of the extra term here. So in order to get it by itself, I will first add z to both sides. So at that point, we have a square root of 64 minus z, and it is equal to 8 plus z. Now, the way that you cancel a radical is by raising both sides to the same power as the root. And in this particular case, when there's not a root shown, it is understood to be a root of 2, what we call a square root. So we will raise both sides to the power of 2. So that cancels the radical on the left, leaving you with just 64 minus z. And on the right-hand side, when we square that binomial, it's important to remember that you have to FOIL. You cannot just distribute the squared power. So what I'm going to do is I'm going to write it as 8 plus z times 8 plus z. So when we FOIL, we first take 8 times 8 is 64. On the outside, 8 times z is a positive 8z. On the inside, z times 8 is a positive 8z. And on the last two terms, z times z is z squared. We realize at this point that this is a quadratic equation because of the squared term. And the way that you solve a quadratic equation is by first setting it equal to 0. So I will move everything to the right-hand side since my squared term is positive over here. So I'll subtract 64 on both sides. That's going to zero it out actually on both sides. And then I will add z to both sides. So at this point we have a 0 equals, and I'm going to put my terms in order, so pull the z squared to the front. 8z plus 8z plus 1z gives me 17z. So notice that the two terms on the right have a factor of z in common. We will factor that out. That leaves me with z plus 17. And then we set each factor equal to 0. So one possible answer says z is 0. The other possible answer, when I subtract 17 on both sides, tells me that z is possibly negative 17. Now, it's very important that when you're solving radical equations that you always check your answers. So I have gone to my Desmos scientific calculator and I first plugged in 0 for the z value here and here. And you'll notice when I hit enter, it equals 8, just like it should have based on the original problem. But notice when I plugged in the negative 17 in terms of z, and I hit enter, it equaled to 26, which is not correct because, based on the original equation, it should equal 8. So we throw that answer out, and z equals 0 is the only answer that we keep. Okay, so with this next radical equation, you'll notice that there are two different terms with radicals. We have to have at least one radical by itself. So we will come in and first add this second radical to both sides. That way we can the other side. So we have a cube root of 11 minus 5x, and that is equal to a cube root of 7x plus 8. Now, in order to cancel this cube root, we will raise both sides to the power of 3. So that cancels the radical on the left, leaves me with 11 minus 5x. And it also cancels the radical on the right, leaving me with 7x plus 8. Notice this is just a linear equation at this point because there's not a squared term. So I need to get the x's on the same side. I would probably add the 5x. Does not matter which side x is on. I like to keep things positive, so I'd probably move that. So 7x plus 5x is 12x. And then subtract 8. So you're left with 3 is equal to 12x. And if I divide both sides by 12, I have a fraction that x is equal to 3 divided by 12, but that is going to reduce to 1/4. So finally, I went into Desmos and I took my answer of 1/4, plugged it into my original equation right here, and when I hit enter, it equaled to 0, which when I look back at the original problem, that's what it should have equaled. So I now know that my answer of x equals 1/4 is true.